So we are going to continue talking about joints, that this is the chapter 9 in your textbook. In this section of the lecture, we're going to talk about the movements at synovial joints, and they will be divided in 4 different categories. That is the way that your book organizes it. And we're going to start with the first one, that is the gliding movement. And in this case, you can close your hand as if you were going to punch somebody. I try to move your hand back and forth, side and side, side to side. And here is an atypical movement. Yeah, you cannot move your knee or you cannot move your elbow in this way. If you do it, you will get injured. So remember, this is because there are gliding movements. The second type that we're going to talk is special movements, and those one occur at a specific joints. And here there is one example. You will see a list of many, and here in this example I am showing you one that is called opposition. Again, you can take your hand. If you want, you can join your thumb on any of the other fingers. It's called that is called an opposition movement. It's a special movement. So gliding back and forth, that is when you move back and forth and side to side, the special movement that occur at specific joints. And the third one is the angular movements. And an angular movement is a change in an angle between bones. Good. So what happened here? There are many examples. I'm just going to show you one. Here you have the middle, the midline, again, crossing this part. Now, if you have two bones, you can go toward the midline or you can go away the midline. Yeah, if you go away from the midline, for example, you will have a change in the angle. This will be around 90 degrees. There was an increase in the angle. So let's put a plus. And if you move toward the midline, you will have something like this. Let's suppose that this is 20 degrees. Yeah, so you decrease the angle. Yeah, so it will go toward. And there are many examples. In all of them, there is a change in the angle between bones. And we will describe other types, but this is the key idea. So remember, glided movements back and forth, special movement occur at specific joints, and angular movements that they change the angle between bones. The fourth one that I wanted to show you is the rotation. And the rotation, in this case, you have the bone rotate along its axis. So it's longitudinal axis. So here in yellow, I add a longitudinal axis. So here you have it. And you can move like this your neck and move your head. Yeah, so for example, cool fact, well, we restricted, we only have almost like 90, we can move 90 degrees almost rotate our head. Some birds can rotate much more. Some of them even almost 360 angles. So pretty cool adaptation. Okay, so I told you about these 4 type of movements at the synovial joints. Here, if you want, you can read it in your textbook. I'm going to provide other videos in case that you want. And now, if you want to continue the lecture, um, I'm going to explain each one in a more specific, in a more detailed way. So if you want to stay with me, please go ahead. So here you can see the gliding movement, and here you will find the description. This is found in the table 9.1, and there is a table with each one of those. I highly recommend that you want to get an A+, a good grade in this course, that you do, in addition to watching this lecture, you also read the textbook. So the first type of movements are the glided movements, and I already showed you that they were back and forth or side to side. Now I wanted to show you this video that explain why they are able to do that. Yeah, because the joints occur between bones that, if you see, they are flat. Yeah, so they can move in different directions. Now I wonder you think about the angle of change. Do you, is there is a big angle of change? Could you rotate it, you know? Could you put your hand close to your arm? Yeah, when you stretch it, could you put it completely backwards? Yeah, could you put your thumb close to your arm? If you try to that, you know that is difficult. Why? Because these only allow a small change in angle. So remember, these glided movements occur between relatively flat bone surface, and they allow back and forth movement side to side over one another, but they allow only little changes between bones. Now here again, this next section of the table that you can read in your textbook. I'm not going to go through all of them. There are too many to explain, but I'm going to show you some examples that appear in your textbook. So now I'm going to show you three examples of these special movements that occur at a specific joints. In the other slide, I will show you another ones, but here the key is that each one of these will be in different joints. So, and it will have different names. So here I add this midline, if you see it here, and here there is another midline in this example number one. And what you can see here is that if the inversion, if your sole move close to the midline, yeah, if you have a medial movement, this is called inversion. If you have a lateral movement away from this midline, you will have an inversion. Okay, so you can go and look in the list. They will have this information: inversion, that is medial movement of sole, and here a version that is lateral movement of sole. Now let's go to the second example that they show you here. Again, now we move from here we have the intertarsal joints. Now we're going to talk about the forearm, and you see that the movement of the forearm can turn the palm, and it can turn it in two ways. So here you have one special movement that is supination, and the other one that is pronation. So if you remember, when we start this course, we talk about prone and supine, that if you're facing up or facing up or facing down in a body position, here is the same logic. So if you palm uh, it moves anteriorly, is supination, and here if it's moving posteriorly, is located posteriorly, is pronation. Okay, so to summarize, you will find in the table this information. The movement of the forearm to turn your palm, yeah, it can go in two directions, yeah. First one, supination, that is the movement, and that is when the palms turn anteriorly, or pronation, when the palm turn posteriorly. Okay, now let's go to the third one that we have here. That is the easiest one, opposition, that I already told you that is the movement of the thumb across the palm that touch the fingertips of the same hand. Yeah, so pretty easy. I think is the easiest one. Here you have always two complementary. Yeah, inversion, aversion, supination, and pronation. Here you just have one that is opposition. However, the joint where it's located is a little bit more complicated to pronounce. So here, carpo, meta, carpal. So all these bones that you will find in your hand. And so carpometacarpal joint. And as I said before, if you look at the table, this is called opposition, and is the movement across the palm that touch the fingertips of your own hand. Okay, so I show you three examples. Now I'm going to show you a few more examples of special movements in the next slide. Now we're going to talk about other special movement. Here we're going to talk about four special movement at a specific joint, and in this case the joint will be the temporal mandibular joint. So here, temporal mandibular joint, and I think it's very useful that we start making connections with previous chapters. So here you can see that if the movement goes is a superior movement, that is goes up, yeah, it will have one name. If it goes down, if it goes uh, back, or if it goes forward, yeah, they will have one different name. And all these movements, if you want, you can move your jaw, you can move it right, left, you can move it to the back, front. I was doing that and I realized that I cannot talk like that. But if you see all these, your the bone is able to move in different direction, and it's very important for chewing. Okay, so let's see these four type of movement. So the first one is called the elevation movement. Yeah, and this elevation movement is an elevation is superior movement of a body part. Pretty easy. The second one, it will be the depression. Yeah, depression here. That is the opposite. The depression will be the inferior movement of a body part. Now the other two will be in a transverse plane. Yeah, they will not be again in the same plane. So you have one that it move in the, it will be an anterior movement. Yeah, so you see it here, the protraction, that it move into that direction, that it move forward. So that this will be an anterior movement of a body part in a transverse plane. And the protraction, again, here it move in this direction. So you can move your jaw, back to some degree. And this thanks to these joints. So this was called retraction, that this one is a posterior movement of a body part in a transverse plane. Okay, so again, this is a good time to start making connections. And if you start making connections to different chapters, you can start finding the answer in a much easier way. With this, we finish the special movements, and now we're going to go to uh, another type of movement at synovial joints, that are the angular. So now here you see that there is plenty of material that you can cover. And now I'm going to, you can read it in your textbook, or you can read it here and take notes. And I'm going to explain some of them that they appear in your textbook. Now we're going to talk about these angular movements. And here you have two types, and you have many examples. Examples in the shoulder, example in the wrist, example in the hip, and example in the joints between the fingers except the thumb. And here you have again a joint that has a very long name, metacarpophalangeal, very long name. But if you remember all the bones, you will realize that it's not as difficult. So here we are talking about angles. So the angles between two bones, if you remember. So you have two type of movements. One that is with 2D, adduction, that is the movement toward the midline, usually in a front plane, and the abduction, that is the movement away from the midline. So if you want, please try to make the midlines of each one of this, yeah, and try to determine when it's away and when is from the midline, and try to guess when is toward the midline. You already have the names there. I just want that you try to make the midlines so you understand much easier what is happening. If you want, you can stop the video. If not, you can just continue watching the video. So pretty easy. The midline of the first one will be here, yeah. And in this case, you clearly see that towards, it will be, let's put this symbol, yeah, it will be lower, or a minus, yeah, lower angle. Here you will have a higher angle, plus angle, yeah. So here you have, when you have abduction, you will increase the angle between bones. You clearly see when you have this angle, each much is much higher than when if you have this angle that it will be much smaller. Okay, so pretty easy. Now in the second one, here the midline in the wrist joint. So here the midline is not going to be going across the finger. Here is going to be still in your the midline is going to be still the one that goes through your head and chest, all similar to here. Yeah, so and in that way you can say that this is abduction, yeah, that you have a lower angle with your body, and here you have, so let's put lower or minus, and here you can have a weight that you have a higher angle or a plus that show the angle between bones increases. In the third one, in the hip joint, of course the midline will be here, and you will have again toward the middle line, the midline, or away from the midline. So here toward lower angle, very clear. Here the angle, if it's away, you start increasing this angle a lot. Okay, so higher or plus. Finally, try to make the last midline. Meanwhile, I try to delete all this information in that one and how you make sense that this was that in that one that is higher angle or lower angle. Okay, so while you thought about it, uh, I delete those things, and now I'm going to show you here, different from the previous example that you have here, that the midline, you are comparing the angle of the wrist. Yeah, here you are comparing the angle of the fingers. Yeah, so here the midline, it will not be in the body. You're comparing how separated or how close are the angle between your fingers in your hand. So here the midline will be here. Yeah, so if they are away, we have been talking that they have a higher angle. So this will be a higher angle. And why? Because you're going to look this. Yeah, you can take it like this, or you can take it like that. It's a big angle. However, if you have all of them closer, the angle will be smaller. Or if you compare like this, the angle also will be smaller. So here it will be lower, or you can put a minus. Yeah, the angles just start getting smaller between the fingers. And with this, we finish this adduction and abduction. If you won't need it, you can rewatch this section. It's not complicated. Sometimes you need to just stop it to see those things. So now I'm going to show you another type of angular movements, and I remind you that angular movements are changes in angle between two bones. So I show you this animation. Here you see the bones are changing in angle. Here increasing angle. Now you see that it's reducing in angle. Yeah, so you're trying to make it straight. Yeah, now you're trying to bend it. So here you have two specific and opposite movements. One is called flexion, and when you're flexing, you are reducing the angle in this case, and when you are extending, yeah, you are increasing the angle. You're going in the opposite direction. So remember, when you are flexing, in particular in this case, you are trying to bend the limb. Yeah. So if you see the diagram, you are bending it, and here there was, as a result of the bending, there is a decrease in the angle. While here, when you are extending it, and now in the animation you see that is extending, what you're trying to make it is straight, and this will lead to an increase in the angle between the articulating bones. Sometimes it's much easier to see in some bones than in other ones, and in some case there is small modification, but this is the big idea. Now I'm going to show you more examples. So I already showed you the example of the elbow, that if you see, I told you when it's extending, you're straightening the structure. And if, let me put now in blue, if you are flexing it, you're reducing the angle. Yeah, it just becomes smaller. Now with the hand is something similar with the rest joint. So here you can see that here when you are flexing it, again, you are reducing the angle. Yeah, it's getting smaller. Here, this is what I put the minus. However, I change color. Now let's see the angle here. Now you have all this angle, yeah, and increasing the angle. While in the other one, if you see the blue one, it was only this angle. So here it was a lower angle. Let's put a lower angle, and here you will have a much higher angle. Okay, now this is not the only example. The elbow, the joint, for example, with your neck, you have other type of joints. You have, for example, the cervical intervertebral joints and these atlanto-occipital joints. So in this case, again, you are going to have, uh, if you, let me put it in blue, here with the medial, you're going to have a lower angle, yeah, this will be lower. However, if you extend it, here the angle, look, it goes all this way. So you're going to have a much higher angle. So this is what I put the plus or the of this. Okay, so hopefully this is clear. So remember, generally in some cases it's much clearer than in other ones. So for example, in the army it was very easy. Sometimes bending tend to bend when it's a flexion, and it tend to straight when is an extension. So now I'm going to show you two more examples of angular movements that are of the examples of the flexion and extension of those two type of movement, and finish with the lateral flexion that is pretty easy. So these examples sometimes are not as straightforward. So this is what I wanted to show you, and I'm going to try to find a way to explain it easier, to not try to complicate you as much. As I said, here we are trying to combine different joints that are different and different movements and try to put it in a group, but sometimes some examples apply, some definitions are more difficult to apply. So here in the hip joint, for example, here I'm making let me put it in black, a midline here, and I'm going to make it here. Imagine that here I'm talking about the head and the chest. Unfortunately, they're not showing here, and this is the line that you use to compare. Okay, so let's compare now the extension. The maximum extension will be here. Yeah, very clear. Here in this maximal extension, I'm going to put it also in blue. You see that there is a low angle. Okay, let's try again blue here. So here you have a low angle. Yeah, pretty easy. I'm going to put a minus. So when you are flexing, you are again decreasing the angle. Now let's put in red the other one. So here you will have, oh, sorry, red. Here, oh yes, red there. So let's change here. And if you see now this angle will, the maximum flexion, it will go up to here. Yeah, so it will be all this angle. So here, clearly you're increasing your the angle is much higher. Yeah, so here you have an increase in the angle or a decrease in the angle, depending if it's a flexion or an extension. Okay, hopefully that is clear to determine how to find the hip joint, how to find what is an extension in the hip joint. And now let's try again with another one that is slightly different, that is the knee joint. And in this case, depending on the midline, is slightly difficult sometimes to compare. I'm just going to go try to do it easier for you. For the knee, just The easiest way to do it is just to compare here. Yeah, find the pen, sorry. If it's straightened, yeah, here is very clear that it's getting straight, so it's an extension. However, if it's bending, look here, I put it in blue. Here it will be a flexion. Pretty easy. Yeah, and with this we finish flexion and extension examples. Now let's move to one that is very easy, that is this lateral flexion. So on lateral flexion, as you can see here, you are moving, um, let's put it in purple, and the entire trunk in the front plane, and you can move it again in the other direction. Again, you are moving away from the medial, you're moving to the you're making a lateral flexion. Okay, so with this we finish a lot of examples of changes in increase and decreases in angle between two bones. Now I'm going to show you one that combine all of those ones. So here you have one that is called circumduction, and here you have flexion, abduction, extension, adduction, rotation, but all of them in succession. So this is how you get all these movements that are very interesting, that you can go in this direction, and you can go here, or you can go in the opposite direction. And that's all. With this, we finish all the angular movements. That what they do is increase, they determine an increase or decrease of angles between two bones. Now we are going to talk about the last one. With this, we're finished. That is the rotation that we already talked a little bit in the previous one. Now I'm going to show you an example. So in case to make it much clearer. Now let's talk about rotation. And in rotation, we are going to divide it into two examples. The first one, it will be in the neck, in the atlanto axis joints, and the other two will be limbs, that it will be the shoulder, and it will require the movement of the arms, or the hip, that it will require the movement of the legs. In the first one, I will put it in yellow, you will have the bone that rotates along its longitudinal axis. So I'm going to make lines here. In this case, it's the longitudinal axis. Here you see the longitudinal axis, and you can see the neck of this person. You can move your neck, and thanks to the atlantoaxial joints, you can rotate it. Yeah, in different. Yeah, rotate your head along its axis. Okay, so what I told you that the rotation occur in bones that move around its axis. However, as I said in the beginning, in limbs, we don't talk about a longitudinal axis. We talk about a midline that, for this purpose, it would look very similar, but we talk about medial and lateral. And I will explain that in a second. So let me put it in green here. Medial, it will be toward the midline, and lateral will be away from the midline. And I'm going to make the midline. Here I'm going to put another yellow line, just because has a good contrast here. So you see the midline there. And here, if you see toward the midline, is this example of the person where it has her arm close to the stomach. So here it will be a medial rotation, that it goes to the toward the midline. And now let's change to blue, and you can see this is the other example. Very clear. It's away from the midline. Yeah, it's away from this yellow line. So this will be considered lateral. Now let's do the same thing with the other ladies. Yeah, in the example of the hip joint. And now you can make the midline and try to make the lateral rotation and the medial rotation. If you want, you can stop the video. If not, I will tell you right away. So here you have, I draw the midline, and if you see Here, if you see the feet here and the entire leg is moving away from the midline. Yeah, you move your feet, your foot away from there. Well, and let me put it in green. If you see the second example, that is toward, if you see the position of the leg and the feet and the foot is also closer toward the midline. Okay, so with this we finish the last example. Now I'm going to play a video for you. If I cannot put it in this video, I will put the link for copyright issues, but it summarizes all the different types, not of movements, all the different type of synovial joints that it allows this type of movements, and that I think it summarized very well, and you can watch it multiple times to see the different type of movements at synovial joints. So to finish this, I'm going to play the video in the next slide. I just told you I talk about the movements at the synovial joints, and I talk about four categories. So I talk about the gliding, and I told you if you close your hand like you were going to punch somebody, you can move it back and forth and side by side, and this is not common. So first one was gliding. Second one was special movements, and I gave you many examples. For example, the one that you have that is called opposition, when you joint your thumb across the fingertips on the same hand. I also talk about many angular movements that are changes in the angle between bones. And finally, I finish with the rotation. If you have any question, please ask me in class, and the textbook is a great source. Now I'm going to play the video, and if you cannot see it, I will put the link because there could be copyright issues. So with YouTube, so I hope that you had a good day and that you enjoyed this lecture. And if you have any doubt, again, just let me know. Bye.
Types of synovial joints. Synovial joints are the freely mobile joints in which the articulating surfaces have no direct contact with each other. Ball and socket, where the ball-shaped surface of one rounded bone fits into the cup-like depression of another bone. It permits free movement in numerous axes. For example, the hip joint. Condyloid contains a convex surface which articulates with a concave elliptical cavity. They are also known as ellipsoid joints. For example, metacarpal phalangeal joint, wrist joint. Gliding plane. The articular surfaces are relatively flat, allowing the bones to glide over one another. For example, acromioclavicular joint, subtalar joint. Hinge. Permits movement in one place, usually flexion and extension. For example, elbow joint, knee joint. Pivot. Allows for rotation only. It is formed by a central bony pivot. For example, proximal and distal radio-ulnar joints. Saddle. Named due to its resemblance to a saddle on a horse's back. It is characterized by opposing articular surfaces with a reciprocal concave-convex shape. For example, carpal-metacarpal joints.
Download our app for fast and easy learning. Becoming a real professional is a couple clicks away.